Welcome to lesson 2.3. So we're continuing on with proportional relationships. So remember, for two things to be proportional, they have to be the same ratio. So now when we start talking about graphs in tables, it's still the same thing. When they're proportional, every set of x and y can be set as an equal ratio to all the other x's and y's. So when we do this, we always do y over x, okay? So y over x, because when we start writing equations, you want to get in that habit. So when it talks about x and y pairs, 4 and 8 are a y pair, x and y pair, 5 and 10, 6 and 12, and 7 and 14. And what we need to do is make sure that they equal the same ratio. So we're going to do the first one. So y is 8 over 4, which is 2. 10 over 5, which is 2. 12 over 6, which is 2. And 14 over 7, which is 2. So you notice how all of them equal 2. That means that this is a proportional relationship. All the y's and x's, when reduced, are the same ratio. So they're all 2 over 1, or 2. Okay? So now we're going to look at the graph. So the equation for this table, so proportional relationships are y equals kx. So we find k by doing y over x. There is no, and it always goes through the origin, okay? So if you're looking at a graph, it has to go through the origin for it to be proportional, and it has to be a straight line for it to be proportional. So for this table and this graph, the equation is y equals 2x. We found the 2 from when we divided by 2 on everything, and then we used the form y equals kx, so k is 2. So when we're checking if tables are proportional, we always set it y over x. If everything matches, then yes, they're proportional. If it's a graph, you're looking for, is it a straight line? Does it go through the origin? If those two things happen, yes, it's proportional. And then when you're looking at equations, does it fit the format y equals kx? Yes, then yes, it's a proportion. If it doesn't fit that format, then no, it's not. Okay, so now let's open up. So we're going to determine whether these are proportional or not. So when we look at y equals 3x, think about this. This is y equals kx. K is going to be a number. So because of that, this relationship is proportional. Okay, this one is proportional. Y equals x plus 5, that does not fit because y equals kx. We don't have any addition on there, so that means that one is non-proportional. It's linear, and we'll learn about that later in the year, but it's not proportional. This one is not proportional because it has, if it was just y equals 2x, like we got rid of the minus 1, then yes, it would be. But because there's that minus 1, it doesn't fit the format, so that means it is not proportional. Y equals 10x is proportional, and y equals x is proportional. Because it's just y equals x, the k would be considered 1. Okay, so that's for equations. You're literally just looking, does it fit the format y equals kx? Okay, and so then let's look at these tables. So the first things first, if you see a table and you see 0, 0, that's your first point of, yes, this might be a proportional relationship because 0, 0 is going through the origin. Okay, that's the origin. So we're going to check the rest of the x's and the y's to make sure. So I'm going to do y over x. So 4 over 1, 8 over 2, and 12 over 3. Okay, all of them reduce to 4. So it goes through the origin, and it has all of them reduced to the same number. So yes, it is proportional. Okay. The second one, this one does not go through the origin, so you can already tell this is not going to be proportional. Okay, that's your first indicator. But you can also check this as 8 over 1, 10 over 2, and 12 over 3. That reduces to 4. 5, and 8, those don't match. Those are not the same number, so this would be non-proportional. Okay, so you can check for when it's 0, that's one of your indicators, or you can check for other things. You can check the y over x's, because sometimes they won't give you the 0, 0, and you have to check. Okay, so the second one, let's do this. So 15 over 5 is 3. 21 over 7 is 3. 27 over 9 is 3. And 33 over 11 is 3. So all of those equal the same thing. So this one is proportional. Okay. So now let's look at this next one. So automatically I can tell this is not proportional because I have the 0, 5. That tells you automatically this is non-proportional. Now, if you forgot that rule, you can always do the y over x thing and check it. So 10 over 3, 15 over 6, and 20 over 9. Now, you don't have to find, you can write them as decimals, or you can reduce them as such. So 15/6 reduces to 5/3, and then 20 over 9 doesn't reduce. So these obviously don't equal the same thing, so they're not proportional. Okay, and then the last one, remember it's y over x, so 1/2, 2 over 4, 3 over 6, and 4 over 8, and those all reduce to 1/2. So yes, that is a proportional relationship. Okay, so you can always, if they're decimals, you can always divide them. So 10 divided by 3 would end up being 3 1/3, so 3.3 repeating. 15/6 would be 1 1/3, 1 2/3, and so that would be 1.6 repeating. So these aren't going to be the same decimal. Okay, so you can always do that division and check, so you don't have to reduce the fractions. Okay, so now let's look at the graphs. So remember, for them to be a proportional relationship, they have to be a straight line and they have to go through the origin. So remember, the origin is right here. Okay, there's the origin. Okay, this one, the first one is a straight line, but it doesn't go through the origin, so that means it is non-proportional. Okay, this second one, it goes through the origin and it is a straight line, so it is proportional. Okay, then this one, does it go through the origin? No, it is a straight line but doesn't go through the origin, so it is non-proportional. The two that are non-proportional would be considered linear, and we are going to learn about that later, but for proportions, they have to go through the origin. Okay, so this last one is proportional because it goes through the origin on the graph. So that's it for lesson 2.3. Bye.